Well, g'day, Flatties and Globe Defenders. It's Critical Think from Down Under. And today we're going to have another look at ships over the curve. Yes, indeed, they do go over the curve, but the Flatties have a lot of excuses. And they try to explain it away with reasons that don't have a scientific basis. And we're going to look at ships over the curve. And we're going to look at some of the excuses that Flatties give to try to explain it. For this series of observations, this is my observation point. It's Gander and Lions Club of Redcliffe Central Coastal Arboretum. So you can see now I was standing about there, and that was for my high point, and my low points is one down there above the rocks and one just down on the rocks down there. Now I choose this spot because it's got a good view of the ships over in the port of Brisbane there, and there's a shipping channel across there, and you'll often see ships out there about 12 kilometers away. I've taken some observations from 3 different heights, all on the same day at around about the same time. I've not come back on a different day and waited for the conditions to suit. I know some flat earthers take a picture on one day and then take a picture on another day, and they try to compare the two like Ranty does with his clear day and not so clear day. You can't compare those exactly because the refractive conditions are different on the days. The refractive conditions are different on each day, so you can't really compare what you see, because what you see depends on the refraction. But here I can depend on what I see from a low height and a higher height, because the refraction is constant. It's the weather is constant on this particular day within the 15-20 minutes, half hour that I'm there taking pictures. So I've got my independent variable, which is the height, and we'll see what wiggling our independent variable does. So here's from my observation point, and there's if you look down here, that's where my other observation points, and then there's another one closer to the water, and there's the port of Brisbane out there, and I'm going to start this clip zoomed in on a ship. Now the one thing I want you to note here, this is pretty choppy. The wind's blowing, it's chopped up, but you can see the chop is very small. There's no 6-foot waves or anything like that here, and you can see that as you look. This is an observation. You can see the waves moving, and you'll also notice that if you've ever been to a beach, you'll notice that the waves are higher at the beach because the water gets shallower and the water gets higher on the waves. That's just a natural phenomenon that most people are familiar with. So when flat earthers say that the swell gets bigger out there, it's not so true. If you're on a surf beach, and this is not a surf beach, this is in a bay, it's protected, the waves are bigger at the beach, and while you can get a swell in the ocean, this is a bay, it's not an ocean. But anyway, we'll go on. So here's what the ship looks like. When you've got enough height, you can see the bottom of the ship. You can see the red band there, containers very clearly, and just for Phuket words edification, you can see the colours of the ship too. Now I've gone down the hill closer to the surface, and you can still see there it's choppy surface. There's no huge swell, but there you can't see the bottom of that ship. There is a bit of an inferior mirage. You can see along the surface of the water there, just above the surface. I'm not going to argue about where the real surface is, or which part is air and which part is water. That's an argument for another day. but you can see that let's just say that the way the water is there, that is the real horizon. Let's just say that, but you can see that there's still plenty of boat missing below that. Forget about how much the inferior mirage might eat up. I don't care about that. There's still boat missing. And if you go further down closer to the water, there's more boat missing. And yes, you can see all the colours of the boat. Yes, we have a camera that we can zoom in, and a good camera that we can zoom in and see. So as I get lower, this is my independent variable, my height over the water, the ship starts to disappear bottom up. And this, I will show a little bit later, this is not possible on a flat Earth, easily explained on a globe. So here is a ship that I've captured. It's about 11 points, nearly 12 kilometers away. And you can clearly see that the ship is on the horizon. You can see the red band at the bottom. A lot of ships have that. And you can see the colours. You can see that there's something really wrong about this according to the flat Earth. The fact is, I'm about 15 meters in height, but the horizon is not there 15 meters high on the ship. The ship is on the horizon. This can only mean one thing, Flatties. The ocean curves away. You don't see it go off into the distance. And if you're thinking, as some do, that, oh, that's just the limit of sight, you can't see beyond that, that's why you can't see the water. Well, I've got a picture here that will cover that. You can see beyond this ship on this day quite easily. So you can forget about that excuse. Now, here's as I get closer down to the water, I see this same ship, but oh dear, it appears as if the whole hull is missing and it is obscured bottom up. But we can still see the top of the ship. We can still see the colours. We can still recognise it as the same ship. So here's the ship. It's aptly named the Brisbane. It's a hopper dredger. And here's its coordinates on this day. And you'll see that it also says distance from my location, 6.32 nautical miles, which is approximately 12 kilometres. And here I've plotted out the position of the ship and the position of the observation point, and that's 11.66 kilometres. And yes, my zoom lens has no problem reaching that far. So let's look at that again. There's the ship, and there's the ship obscured bottom up. So the only difference between these two observations is this one I'm higher, this one I'm lower. Now we'll start to deal with the excuses. That's some people say that, some Flatties, they say that this here is obscured because a small way, I'm struggling to explain it, but a small object can obscure a larger, more distant object because of perspective. And yes, that is true if your camera is below the height of the small object. Otherwise it is not true. It's typical of Flatties to come up with a statement that's true, but then they take it all out of context. So if your line of sight is above something in the foreground, then what's in the background will not be obscured. If you don't believe me, just go to any fence and put your eye level below the fence, and then put your eye level above the fence, and how much does the fence obstruct then? Can you see what's behind the fence? Right, so in this case you can see the size of the waves. That's zoomed in, so they actually look bigger than what they are, and you can see that they're not very big. Now that amount of that ship that's missing is about 6 metres. So was there a 6 metre swell that day? Well, I've shown you the pictures. No, there's no 6 metre swell. And so there's that particular excuse there. So I'm going to I've got a diagram to illustrate that. So just so that you know, right? Doesn't matter the size of the waves. If your eye level is above the waves, the maximum that can be obscured by those waves is the height of the waves. So if the waves were 1/2 metre and your line of sight, your eye level was higher than 1/2 metre, the maximum that would be obscured of any ship or object would be 1/2 metre, and that's illustrated by this diagram. So it's only if you're going to put your camera into the water that these waves or swell will obscure more of the ship. But we're not doing that. You can see that my camera is clearly well above the water. So that's that excuse. Now I've also heard Ranty say something like, oh, this is just a tidal bore, or something, and he said it like waves and that. But here's the funny, crazy thing about this. They laugh and they say it's ridiculous that we think that there's a hump of water there, and yet they explain it away by explaining that there's a hump of water there. Go figure. Now, the other thing is, we never see this. If there was a swell, how come is it that every time there's a swell like this, it is always parallel to the ship, between the ship and the observer? In a flat Earth's mind, it is all, the swell only ever travels in one direction, and that magic direction is from the ship to you. But that doesn't happen like that. You see those ships that I took in the port of Brisbane, they were at like 90 degrees to that one. So we really should be seeing something like this if there was such a big swell that would obscure the complete hull of the ship. But we don't see that, do we? So that's why ships go over a curve. Now there's another excuse I've heard, and this is a favourite one of Gary's, and there's some instructions for you, Gary, further on in the video. But this is a favourite one of Gary. So he takes something, again, taking something that is true and then using it out of context. So the thing is, if you're 15 metres high in observation point and you move to 1 metre observation point, the surface detail will get less. You'll lose resolution on some of this surface detail along the bottom here, and in this area things will start to blur, and this is a fact, agreed to that. But then people like Gary Wybinga seem to think that affects the bottom of the ship. You can see that ship there. You can see that it's actually at 90 degrees to the surface. Now I don't know how anything happening on the surface can possibly affect the visibility of the ship above the surface. And this diagram I've given here shows fairly clearly that you've got clear line of sight to the ship. So even if you do lose some resolution on the surface, you can still see all of the ship and the bottom is not cut off. But that's not all. Look at these angles. They're so minuscule. 0.074 degrees and 0.005 degrees. Such a tiny change in angle. It's really not going to make that much difference and cause 6 meters of ship to disappear. And there's another argument about angular resolution, and as you get lower, the angle changes, similar to the previous scenario, but let's apply it in this case to the angular size of the hull of the ship, which in this case is 6 meters. So as you go up in height, the purple line is what you're looking at, and there is an angular size for that ship. As you go down, you've got the dark green angular size, and as you go close to the surface, you've got the light green angular size. Now these are the angles A, B and C, and for this 12 kilometers, nearly 12 kilometers there, and the small distance you go up and down, for all practical purposes A, B and C are equal angles, so there's no discernible change really. If you can detect a change in that angular size, then good on you. Let's see you do it. So here I'm going to calculate the angular size of the bottom 6 meters of this ship when I'm at 15 meters, and I use 2 triangles, and one triangle from the horizontal to the top of the hull, and another triangle there which is from the bottom of the ship. So to the top of the hull is an angle of 0.044 degrees, and to the bottom of the ship is 0.074 degrees, so that this angle in here, the hull, the angular size of that is 0.03 degrees. Now if we do the same sums, but this time we're at a height of 1 meter, and you can see that you've got an eye height of 1 meter, so there's 0.005 of a degree down to the surface, and there's 0.025 degrees up to the top of the hull. So that's 0.03 degrees again from the top of the hull to the bottom of the hull. There's no difference. There's no discernible difference. There's no scientific argument for saying that the change in that angle makes the bottom of the ship disappear. Now some of you more desperate flatties might look at this and say, oh look, 0.03 degrees. That's approaching the limit of the resolution of the naked eye, so therefore it can disappear. Well, not quite. You've actually forgotten about one key thing. I'm using a zoom lens. So in fact, my zoom lens has a resolution of much less than 0.02 degrees. So I'm sorry to disappoint you, but I'm not looking at this ship with the naked eye. So, here's some commenting rules for flatties, and that means you too, Gary. Just one thread. Don't start many threads. If you start many threads, I'll be deleting threads. And I'm going to create a special thread just for you, Gary, because I know you'll come and make some ridiculously silly comments. But here's what I would like you to try to do, is address the evidence presented here. And this applies to all flat earthers. Rather than just posting insults, address the evidence. And if you think I have made a mistake or I am wrong, then bring forth your argument in the form of a diagram with meaningful numbers, right? Like I've done here, I've put meaningful numbers in. So that's it. Now I'm going to leave you with some words of wisdom from another flatty.
We're always told that ships get to the horizon and then they disappear from the bottom up. This is simply one of those fallacies that has been perpetuated to perpetuate the belief in the globe. The ships will just get to the horizon and then they will remain on the horizon as they travel off into the distance. Well, obviously you can see they're quite far away, but that's what they do. You know, you can't tell from here or any kind of zoom whether they're disappearing from the bottom up and all that rubbish. They just get to the horizon and remain on the horizon, and if they carry on going off into the distance, they just get too far away to see. Even if we're using very high quality optics, there's a limit to how far we can see. From this great distance, we can't make out any colors of the ship. That could be a bright orange or yellow or red ship. We simply can't tell because it's so far away that the color of the light, you know, and colour is reflected light. We all know this. And so the colour just isn't reaching our eyes. So you can see how eventually this ship that's on the horizon will just become part of the horizon. It will just converge with the sky and everything. So, you know, and it's obviously not disappearing from the bottom up. You can still make out it's definitely the shape of a ship. Okay? So, you know, don't let these people tell you that ships always disappear from the bottom up. That is just ridiculous.